Hello students. So today in this particularly online video class, what we are going to discuss that is actually regarding the competitive classes. We are going to discuss about one of the module. So before starting to continue, so let us just see what and all things we have done before the lockdown. So soon after your preparatory examination, of course, public examination was there. One of the exam is remaining. So before that, the entire year we have discussed different topics. Many times it has repeated, and few more topics are there which is already discussed, but still some of you have asked. So what we do is we are not going to directly start with some of the topics which is being requested for. Okay, that class should be engaged. Now what we do is we will be discussing the entire topic. That means for first PU as well as second PU. So both we are going to merge. Around 20 modules we are going to do. So one by one we are going to discuss. So in each session we will be having 30 questions. So the 30 questions hope already you have received, and just try to solve all those. And however, I am going to solve all those 30 questions here in this video class, and hope it will be very informative for you people as well as a very good training as well. So stay safe, stay at home, learn thoroughly, and it will be very much important for you people because the competitive examinations already the dates have been scheduled. So learn well. So today we'll continue. So today's topic, that is P01, that means module. So that is P01. The topic name is units and measurement. So of course you know first chapter it is about physical world. That is all about something like the basics regarding science. But what is most important for your competitive point of view, that is units and measurement. I have taken this one as a one particular module, whereas the remaining modules, yes, some of the chapters will be clubbed up. So let us go for units and measurement topic today. So now, while watching this particular video, better you write down already what and all the question paper you have got. That means P01 PDF document you have got. So you will be having the questions. So better you write down those, leave some space, try working out. If not possible to solve means it's okay, leave some space. However, we are solving here, you can take it down. So around 20 module you will be getting in the notes you can prepare. So it will be very much useful for you. So let us go for the first question. So let us see what is the first question was. So question is, the accuracy in the measurement of diameter of hydrogen atom, as they have given diameter of the hydrogen atom, that is 1.06 into 10 power minus 10 meter. And the options they have given, that is 0.01, 106 in 10 power minus 10. Third option is 1 by 106. Fourth option is 0.01 in 10 power minus 10. So all these are actually values which is actually should be represented in terms of accuracy. So now diameter they have given, and now let us see the value of the diameter is 1.06 10 power minus 10 meter. The order of this one you can see. Now what I do, let us go for the concept of relative error. What is that relative error? Yes, it is change in, that means how much error might be present. Okay, relative error in that one. So what is delta D here? The small change, that means error which is actually going to be there, but in the question it is not at all mentioned. So you can see here what is the least possible value of error that can be possible in this particular value. Least means 1.06 it is there, that means some value suppose you put, means you can see the minimum deviation of the value. That means minimum deviation means minimum error. Hope it is understandable for you people. Minus 10. So the least value of deviation possible in this kind of number which is given is, here 3 digits are there with one particular decimal point. Yes, you can see 0.01. That means least deviation possible. So what is D actually? Already given in the question. It is 1.06 into 10 power minus 10. And next, let us see. So finally, the least deviation, what you can see is this can be represented the accuracy of this particular concept 106. So what you can say, the option is C, or option is third option. So that's all about the first question. The first question what is asked here is the accuracy in the measurement of, that means what we have taken, the least deviation. What is this? Least deviation or minimum deviation possible here. Okay, that is 0.01 in the given. That means in this, what is the least value of deviation? That is 0.01 is the possible one. Let us go for the second question. Second question is, length of the rod is measured as 31.52 centimeter. Graduation on the scale are up to. So length is given. L is equal to 31.52 centimeter. And graduation on the scale are up to. So they have used one particular instrument to measure this length. And you can see 31.5 it is written. In our usual scale, suppose you start measuring means, yes, you can see in millimeters small scales are there, but whether it is possible to go for the fourth digit here, that means after the decimal place, you can see here, that means what is the least count possible here? Least count of this measurement, that is 0.01 centimeter. What is least count? Least possible measurement that can be done by using one particular instrument, measuring instrument. And here measuring instrument, this particular measuring instrument has shown to this kind of resolution, so 0.01 centimeter. So our answer should be 0.01 centimeter, but none of the options is not suitable. So what I do, I'll just show this one in some other term. What is that? 0.01 also can be written as 0.1 millimeter also, correct? So 0.1 millimeter. So let us check whether the option is present there. Yes, third option, that is 0.1 millimeter. So that is about the second question. Let us go for the third question. So third question I will write down here. So take down these points. Next, let us see. The question is, if L is equal to, third question, if L is capital L, they have given L is equal to 20 plus or minus 0.01 centimeter, and capital B, they have taken some physical, like we can say length and breadth like that, just for whatever the values they have given, can assume like that. Yeah, so 10 plus or minus with the particular error present in that one, 0.02 meter it is, sorry. Yeah, right now they are asking, then what is L by B? So what is L? Is one of the physical quantity, B also a physical quantity. They are asking the reciprocal, that means ratio of that one. Now ratio of this one, how to find out? Because it is not just a number where it is given like just 20 and 10 where we can just say that answer is 2, but along with that they have also included the error which is present in that one. Now what I do, first I will go for, I will just take one particularly one unknown value, that means L by B will take X equal to L by B. So what is L? 20 divided by 10. What is the answer for L by B? That is 2 meter I will take. Next, whether we can neglect this? No, because it gives the most precise value. That's why we have to include the error itself. But along with that, we cannot directly just add up or something like that. We have got a set of formulas for that. That means to find out the error in that. So how to find out error? You might be remembering the formula. I will take delta x by x. What is delta x? That means error in the value of L by B. Delta x by x I have taken. And next, what is delta x by x? that is equal to relative error in the L value plus relative error in the B value. So when you go for this, you will be getting the answers. Let us see. So we require what? We know already what is x. What we require now? What is delta x? So what is delta x? Let us see. So delta x can be written as what? Equal to x into delta L by L. So I will just substitute the values here. So what is delta L? Delta L is 0.01 divided by what is L? L is 20. So next, that is delta B, that is 0.02 divided by 10. Value of x is known. So one more substitution I will do, that is this is 2, and here 10 into 0.01, I am taking the LCM over here, plus next here, that is 20 into 0.02, then like this we get, and soon after the substitutions and all, what you get is delta x substitution you can do 0.0025 you will be getting. Then let us continue further. So I will continue here. Okay, so delta x is equal to 0.005 meter. So error in the measurement, yes, of course you can see we have got the value. Error in the measurement starting from, yes, L value they have given, B value also they have given, and next you can see there what we require L divided by B. So substitutions we have done here. Soon after the substitutions, yes, finally we arrive at delta x equal to 0.005 meter. So therefore, how to represent this? We require x plus or minus delta x, and what is that now? So is equal to 2 plus or minus 0.005 meter. So this is all about the substitution. So it's one of the very important topic it is regarding the finding out the errors in the measured data. So hope it is clear for you people. So let us continue. So let us go for the next question, and the question number is question number 4. So I'll read the question. Question is, the radius of a sphere is measured as, radius it is given. So question number 4, radius is given by r is equal to 10 plus or minus 0.02 percent centimeter it is mentioned. The error in the measurement of its volume is given. That means error in the measurement of its volume. So how much is that? Let us see. So we require what? We require error in the measurement of value. That means error in volume, delta V is equal to how much? Now see the previous question, whereas the given data is having the numerical values like this. But here you can see the error they have mentioned here, no, that is actually given in terms of percentage. Whether we are able to directly solve like previous questions, it is not. So we should be very careful in such case. Radius is given and it is actually a sphere. Sphere means we know what is the standard formula for volume. V is equal to 4 by 3 pi r cube. Suppose according to the formula, the set of formulas you might be remembering, suppose I want the relative error in this particular volume is delta V divided by V is equal to, so these are constants, have no, what is that? Yes, importance. So this is, yes, n into delta R divided by R. So this is actually the formula now. And we require what? Error in the volume. So error in the volume what? Delta V is equal to 3 into delta R by R into V. So this will be the formula which we require right now in order to find out the what? That is the error in the volume. Now what is delta R by R? Because here you can see delta V means, yes, of course formula is there, not a big deal. But what about delta R by R? That is a question. So V here you can see. So what I do? So first I will go for substitutions. What is that substitution? Now they have given error in the radius, measurement of radius, delta R by R into 100% is equal to 0.02, like this. So what is delta R by R now? Then it should be 0.02 divided by 100. Hope you understood how we got this particular value here, because they have mentioned not delta R by R. What they have mentioned? In percentage they have mentioned. That is why this rearrangement I have taken. So now what I do? I will just substitute this one in the standard equation. Therefore delta V is equal to 3 into, what is delta R by R? Delta R by R is 0.02 divided by 100 into what is V? V means volume. Where is volume? Here. So how much is that? 4 by 3 pi. Pi means 3.14 into R cube. R cube, R, yes, you can see. That is 10 cube. I'll just write like this, 10 into 10 into 10. Now let us go for the substitutions here. So this can be cancelled. And next, what else can be cancelled? This can be cancelled. And finally, you will attain the value, that is delta V is equal to 2.512 cc. So delta V, sorry, this is delta V. So delta V, that means error in the measurement of volume. We arrived at this particular equation. So why we have discussed this particular numerically is, in some of the cases in competitive examination, if they give the values in terms of percentage here, remember you cannot substitute like the previous equation, that means numerical. There should be some rearrangement what we have done here. So make a note here. This is the way of understanding this particular or this type of numerical. Hope this is clear for you people. So that is all about the question number 4. So question number 4 is already solved. Let us move on to the next question. And next question, I'll read the question. And the question is, if length and breadth of a plate are, values are given, length and breadth they have mentioned. So length I will take first. Question number 5. So length L is equal to 40 plus or minus 0.2. It's mentioned in centimeter. Next, breadth also given. So B is equal to, what is the value? 30 plus or minus, and the error which is associated with that is 0.1 centimeter. Now what they are asking, the absolute error in the measurement of area is, absolute error in the measurement of area, that means what exactly or how much is the value of error in area. So area value you might be knowing. So right now they have given it's a plate, that means area can be directly written as the formula, basic formula, L into length into breadth. So what is the value here? I will take directly 40 into 30, that is 1200 centimeters square. Value of A is done. Now what we require here, absolute error in the area of this particular plate. So for that, what we are supposed to do, let us go for, yes, the equation, standard equation in finding out the relative error, that is delta A by A is equal to error in measurement of length plus relative error of breadth. Next, we require only delta A here. So it is A into delta L by L plus delta B by B. Almost similar to the previous numericals itself, slight change is there. Next, delta A, error in the measurement of area, is equal to A. How much is that? So 1200 into delta L. Delta L means error in the measurement of length, that is plus or minus range they have given. To that extent it might be varying. So 0.2 divided by 40 plus next measurement of breadth, error in that range is to 0.1 and 30 is the given value. So after substitutions, what is the substitutions you are going to get? Delta A is equal to 1200 and here I will go for LCM and that is 0.2 plus 0.1 into 40, so 1200 cancels. So what remains here? So this is, therefore we get delta V is equal to, so area, so delta A is equal to error in the measurement of area. So it is here 6 plus 4. So 6 plus 4, the answer is 10 centimeter square. So what is the error in the measurement of area which is possible in the current reading, that is 10 centimeter square. So that is about the question number 5. So let us move on to the next question, that is question number 6. So let me read the question. So that is, this question is not about measurement of errors. This question is regarding the significant figures as well as the rounding off concept. So question number 6, and the question is, the value of 103.5 kg is rounded off to 3 significant figure, then the value is, they have given the value is 103.5 kg rounded off to 3 significant figure. That means round off to 3 significant figure. I just written like this because just to make understand easily. 3 significant figures, values are, options are given there. Rounding off to 3 significant figures here. I am going to rounding off, along with that significant figures also should be mentioned. 103, I will write on here 0.5. Now there is a rule. Suppose the last digit which is preceded by a even number means it cannot be rounded off. Why? Because the 5, the last digit is not preceded by, in the sense further there is no digit at all, because suppose it was 1, 2 something like that means yes, of course previous, though it is even or odd, it has to be rounded off. Now 5 is not again preceded by any of the numbers, so it is a dead end here. So but still in case of odd number we can round it off. So rounding off, so this becomes 104 and round off to 3 significant figures. So that means only 3 significant figures should be there. Significant figure in case of non-decimal place, that means extreme left non-zero, extreme right non-zero, so non-zero. So of course answer should be 104. So option is option number 3. So that is about question number 6. Question number 7, let me read that question. The question is, number of significant figure in 6.023 into 10 power 23. So they are asking number of significant figure in this case, and the value is 6.023 into 10 power 23. Have I got a number? This is per mole. Whatever the given number, in case of scientific notations, though the number is raised to whatever the extent, suppose the number is made larger or much smaller, if it is written in terms of scientific notations, this doesn't matter in case of telling the number of significant figures. So what is the number of significant figure here? It's a decimal number. In decimal number, extreme left non-zero, extreme right number may be 0, but here it is not 0. So of course we can say how many number of significant figures? 1, 2, 3, 4. So answer is 4. Hope it is clear for you people. The scientific notation, whatever the number is to be raised, in case of making the number larger or smaller, it doesn't matter. All that matters is how much or how many numbers of digits are kept. That means made. That means written here. So if you reduce this one, it will become 6 point or one more digit will be 60.23 some 0 will come, like that it goes on. But extreme right, in this case 23 it is there, so it doesn't matter because it's scientific notation. That is why. So answer is 4. Next, side of a cube is, that means question number 8. So let me write directly here. So side of a cube, 8th question, side of a cube is 2.5 meter. So let me take L is equal to 2.5 meter. The volume of the cube to the significant figure. So we are supposed to write down the volume equal to how much along with the proper significant figure. For the formula is V is equal to L cube. That means 2.5 cube. What is the answer you get is 15.623 is the answer. But let me check the options. Answers are 15, 16, 1.5 and 1.6. Look at here. In case of multiplication, while writing the answer should contain least number of significant figures. You can see there 2.5. How many number of significant figures? 2 significant figures are there. So the answer should contain only 2 significant figure. But here 1, 2, 3, 4, 5. So how to write? While writing this, you can see there the number is 0.623. So we can round it off to 16. So this is 16 meter cube, and the option is option number 2. Let me go for the next one. Next question is 9th question, and the question, when force is expressed in dyne, the number of significant figure is 4. You might be knowing what is dyne is actually. There are different fundamental units are there, in the sense different types of expressing the units. CGS system, FPS system and MKS. In the sense right now it is SI system. Right now they have given a force is expressed in dyne. Dyne means CGS system it is. The number of significant figure is 4. So if force is expressed in CGS system, the number of significant figures is found to be 4. Okay. Next, what else is there? Question number 9. Continuing, it is expressed in Newton. In the sense, Newton means of course it is SI unit. The number of significant figure will become, of course we know, 10 power 5 dyne is equal to 1 Newton. Correct? Or we can say 1 dyne equal to 10 power minus 5 Newton. So now what we say is, though it is interchanged, the power will be raised. So what we can say from this one is, you can make a note, that is the number of significant figures when it is multiplied with a constant, it never changes. So just write down one note point there. The note point is, the number of significant figure will be same if any number is multiplied by a constant. So significant number will be always remains same. So this is what we can understand from this one. So the power will be raised. There is no change of any one. That is why in CGS system, suppose it is having 4 significant figure, means in SI system when it's expressed that is interchanged, it doesn't change because it is a constant. So next, let us go for question number 10. Question number 10. might be it is very interesting. You can see here, it looks very simple question. Root of 2.0 is. So root of 2.0 question it is asked. So what is the root of 2.0? Let us see. Okay. So options are given there. Yes, of course, you might be knowing. Suppose you check in the calculator also. It is 1.414. That is root 2. But here they have mentioned very clearly 2.0 it is. So 2.0. That means you cannot directly just say that it is 1.414 because proper decimal place is already mentioned here. So our answer also should contain the how much number of significant figure is mentioned here. That is why 1.414 is the answer. But according to the given data here, this is 1.4 should be the answer. So this is what the answer is acceptable, and the option is, that is option B. So hope you are understanding it very clearly. So that is about question number 10.